So this should be a rather short video. We are talking about inequalities, and that is really fat, so let me bring that down a little bit. You know that the prefix in means not, so we're looking at something that are not equal. It's not just equal. This side here is equal to. This side here is greater than. This would be an inequality. This is not just equal to. I want all the values of x that give me something greater than 11. This is an equality, an equation, an inequality. Okay, so really quickly, let's just solve this side. Draw my line, circle my variable. I'm going to subtract 1, divide by -2, or multiply by the reciprocal. X equals -5. -5 on my number line is somewhere here to the left, and I have a value of x equals 5. That is the only solution I can plug in here to get 11. I can't plug -4 in, I can't plug -6 in, I can't plug +1 in. The only solution that will work in this equation is -5. Now let's look at this inequality. We do it the same way. We're going to draw the line down the inequality. We're going to circle the variable, and I'm going to solve it the same way. I'm going to multiply by the reciprocal. Remember, this is -2 over 1, so I'm going to multiply 1 over -2. -2 over 1. Again, over here, I'm going to multiply by 1 over -2. This becomes -2 over -2, which will give me 1. 10 divided by -2 is 5. Now, here's what we have to remember, is when we multiply or divide by a negative, we must flip the inequality. So let's pause the video right now and write that rule down. Okay, now on a number line, I'm looking for all solutions of x that are less than -5. So I'm going to put on my -5 again. Here's 0. Here's -5. I want everything that's less than -5. So I don't want -5. But I want everything that's less than -5. So remember, let's pause and put some more notes on about open circle, closed circle. An open circle means is greater than or less than. A closed circle is for greater than or equal to, less than or equal to. Okay, so one more thing real quick is you could either do it on the line or you could do it right above the line. But what this indicates is all of these solutions, if I were to put one of them in here, they would give me a number that's greater than 11. I can put -4.5, I can put -10.1, I can put -6. I just can't put any of these numbers above -5. Here is one example of inequalities that you don't see in equations. This is called an and inequality. And it basically is saying we always read from the variable, so the expression 2x minus 5 must be greater than -3, but 2x minus 5 must also be less than or equal to 8. There are two inequalities, which is pretty easy. Okay, it looks complicated. What do we do with these? We put lines down them. We circle our variable. Nothing's changed. I'm going to solve, and the first step I would solve for x would be to add 5. Sorry. Okay, add 5 on the left, add 5 on the right. But in this case, I have another line. So I also must add 5 on this side. This will give me 2. Okay, now to solve for my variable here in the middle, I'm going to divide by 2. But I'm going to divide by 2 on the right and on the left, and I will get 1 is less than x is less than or equal to 13 divided by 2. We'll use 6.5. Now let's put our line on. Let me get this number line set up. And both of these numbers are positive, so I'm going to put the 0 here to the left. Here would be 1. Here's 6. Here is 7. So my 6.5 is going to be in here. All right, and remember, we read from the variable. So this says x is greater than 1. So I know that means I have an open circle, and I'm going to go this way on the number line. The right side said x is less than or equal to 6.5. I know less than or equal to is a closed circle, and I want to go less than, so they meet in the middle. What this basically says is every x between 1 and 6.5, including 6.5, because I can be equal to it. All of these solutions, if I plug them in this x, would give me something that was greater than -3 and less than or equal to 8. Okay? On this page, I want spaghetti and meatballs. Okay? You'll see what I mean on the next page. I want spaghetti and meatballs. I want this to be greater than -3 and less than or equal to 8. These solutions will do that. Now we want to look at the last example. This example is called an OR inequality. So think about it. You say to your mom, I want spaghetti or meatballs for dinner. Well, on your plate, she's either going to put spaghetti or she's going to put meatballs, but she's not going to put both. You say to your mom, I want spaghetti and meatballs, you're getting spaghetti and meatballs. So this is an OR inequality where it says that I want values of x that meet this criteria, or I want values of x that meet this criteria. On the previous example, I needed values of x that met both criterias. So let's see what this looks like. Again, I'm going to draw a line down the equal sign, circle my variable. I'm going to subtract this 3. I get x. This will cancel, is less than 2. Or, now I'm going to solve the right side because there are 2 inequalities to solve. Circle my variable. I'm going to add 2. I get 3x. This will cancel, is greater than 12. And divide by 3 or multiply by 1/3. X is greater than 4. So I have 2 things here. I have x is less than 2 or x is greater than 4. Now what does that look like on a number line? Let's just get this number line set up. I have positives 2 and 4, so I'm going to put my 0 over here. Here's 2. Here's 4. And what that means is I'm going to look at this first one. I want all values of x that are less than 2, which means I want all values of x that are less than 2. So in this scenario, I'm putting it right on top of the number line. It's pretty hard when you have a number line that's black and you're using pencil, so a lot of times I just do it right above the number line. I don't think it matters. You'll have to ask your teacher. The other inequality says I want all values of x that are greater than 4. So I want all values of x that are greater than 4, which would be these, or above. So again, these are not filled in because I want less than 2 or greater than 4. I don't want 2. If I plug 2 in here, I get 2 plus 3, which is 5. 5 is not less than 5. But if I plug 1.9 in here, I get 1.9 plus 3 is less than 5. That's 4.9 is less than 5, and that is true. So 1.9, which is right here next to 2, will work. But 2 will not work. It's the same over here.